Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready, let's get started. Today we are moving on to talk about integration. So basically in simple terms, when you're saying integration, we are talking about the reverse of differentiation. So remember that when we're looking at differentiation, when you're given a function, y is equal to x to the power of n, and you're asked to differentiate this. So you're going to get dy over dx is equal to, you bring down your power n, x to the power of n, then you subtract 1 from the power as your derivative. So this is what I have illustrated here. Now, in terms of integration, we have got different uh, approaches that we use to different mathematical problems depending on what exactly is required of us. So when we are dealing with integration of polynomial functions, basically we are going to add 1 to the power, right? Then we divide by the new power. So when I ask to integrate, this is the integral sign, x to the power of n dx. You're going to add 1, which is here, the power which is n. Then you're going to divide by the new power, which is n plus 1. Then you add your constant c. So this is what I've demonstrated as well right here. So now this is the integration of polynomials, right? So basically it takes this one here as its form. So it's now a matter of applying it. So when you're given integrate x to the power of 3 dx, applying our principle, you're going to add 1 here to the power, then you're going to divide by the new power here. Ultimately, you're going to get x to the power of 4 over 4 plus c as your answer. We've got another problem here. Problem number 2. It's the same concept. You're going to add 1 to the power, then you're going to divide by the new power, then you add your constant c. Ultimately, you're going to get 2x to the power of 3 over 2 over 3 plus c as your answer. Another example as well here is still a polynomial that we have. Example number 3. It's still the same concept, right? X to the power of 3 over 2 plus half minus the square root of x plus 1 over x to the power of half. So here I just want to stress 2 important points. The integral of a constant, right? Any constant like 1 dx, is going to give you x plus c. So the integral of any constant is going to be equal to x, right? It's going to be that constant multiplied by x. Sorry, so here it's just x is the same as 1x, right? So this is one thing that I want to emphasize here. Then the integral of this whole problem here is still the same concept that we're going to apply. So we add 3 over 2 plus 1. That is, then we divide by our new power, 3 over 2 plus 1, as we've done here. Then the integral of our constant half is half of x. Then the integral of x, root of x, you're going to add 1. Then you divide by the new power. Then 1 over x to the power of half is similar to x to the power of minus half. So 1 here is the one that is representing the negative sign. If you say 1 over x to the power of 1 over 2, that is going to cater for the negative sign. So if you want to remove the negative sign, it's going to get 1 over x to the power of half, right? So it's very, very important for us to be able to recognize that. Then if we get that one, we are going to ultimately get x to the power of minus half plus 1, right? Then you divide by a new power here, and you simplify, you're going to get this one as your final answer. Now that we have done these 3 examples, I want you guys to try and integrate this mathematical problem. Moving on now to a different concept. When you've got a function of the form y is equal to ax plus b to the power of n, basically the way we're going to integrate it is that we're going to add 1 to our power, which is n plus 1 here. Then we're going to divide by our new power, which is n plus 1. Then we're going to get the derivative of ax. So if you've got a function y is equal to ax, the derivative of that, which is dy over dx, is going to be ax to the power of 1 minus 1, which is going to be a power of x to the power of 0. Any number at the power of 0 is equals to 1, which is a multiplied by 1, which is ultimately equal to a. So the derivative of ax is a. So that is why we have multiplied here by a as our derivative. Let's look at some examples for us to get to internalize this concept. So for integrate 2x plus 3 the power of 2 dx. So if you look, this is in the form of ax plus b the power of n, right? Now, how are we going to integrate this? It's the same concept. We're going to add 1 to our power, which is 2. Here we add 1. Then we divide by the new power, which is 2 plus 3. Then the derivative of 2x is going to be 2. Then ultimately, we're going to get 2x plus 3, the power of 3, over 6, plus the constant c. It's the same thing that we're going to do on our next problem, which is problem number 2 here. Ultimately, if we solve it, we're going to get this one here as your answer. Now, we move on now to the third concept, where we are looking at a function and its derivative. So basically, when you've got a function and its derivative, what it means is that if you are given an equation, right, you're able to tell that one of it is a function, and the derivative of that function is what you have as the other function. What do I mean by this? So if you are given y is equal to x, right, then you also have x the power of 2, like this one. So x here is the derivative of x squared. If you differentiate one of these, either this one or this one, you're supposed to get the other one. That's what we mean by a function in this derivative. So if you differentiate, let's try differentiate x. So the derivative of x is x1 minus 1. And this is going to be x to the power of 0, which is going to give you 1. So it means that x here, right, is not the one that if we differentiate it, we're going to get x squared. Let's try and differentiate x squared. So we're going to get x to the power of 2 minus 1, and you're going to get x, right, as our final answer. So x here is similar to x. So this is what I meant by saying when you differentiate one of the functions, because we've got two functions, it's y to the power of x and y multiplied by x, sorry, and y multiplied by x squared, you'll be able to get another one, right? So it means that ultimately you're going to, this one and this one, they're going to cancel out because they are similar. So it means that x is the derivative of x squared. In other words, right? So it's very, very important for you when you're given a problem. Look at it carefully. Do I have a function and its derivative from this? So let's look at an example. Example number 1 here is saying integrate, integrate x squared plus 1 the power of 5 dx. Right. Now, if you differentiate x here, you're not going to get x squared plus 1 the power of 5. But the derivative of x squared, which is in the brackets here, right, is x. So it means that this one here is a derivative of this function. So what it means is when you're integrating it, you keep the derivative, which is x, as a constant. Then you come and integrate this one plus 1 over, you divide by the new power, which is 5 plus 1. Then the derivative of x squared is equal to 2x, right? So ultimately, x here and x here are going to cancel out. And you're going to be left with, on the denominator is 6, right? So it's 1 over 12, x squared plus 6 plus c as your final answer. I've just realized that I made a mistake on the when I was illustrating the previous example where I had x and x squared. So kindly note that the derivative of x squared is 2x, not x, please. Just correct that mistake. Now, we've got another example right here that is saying 1 minus x squared minus 2x minus half. So, if you are going to differentiate 1 minus x, you're not going to end up with x squared minus 2x. But let's try and see that if we're going to differentiate x squared minus 2x, is there a way that we're going to ultimately end up getting 1 minus x? So the derivative of this one is going to be 2x. If x squared is 2x minus the derivative of minus 2x is going to be 2. If you factor out 2, you're going to get x minus 1. But here I've got 1 minus x. So how do I get 1 minus x from x minus 1? I multiply everything by negative sign. So I'm going to get minus 2. 1 minus x. So this one here is similar to this one. Right? Now, 1 minus x here, I also have 1 minus x here. So it means that this is the function and this is the derivative. Now, we apply the same concept that we used before and we simplify it. Ultimately, we're going to get this one here as our final answer. Now that we've tried these two examples on function and its derivative, I want you guys to try and solve and integrate this expression that is here. Post your answer in the comment section. If you've got any problems, kindly let me know so that we can help each other work them out. Thank you.